I think in about a minute, we'll go ahead and start. Our presenters, Santiago and Eduardo, are both calling in remotely. So Wi-Fi could be a little bit dodgy. We're going to hope that the Wi-Fi gods are kind to us today and we don't have any problems. But just to make sure everybody is patient, as technology tends to be a little fickle in remote places. I'm going to go ahead and give a brief introduction to get us started. And Eddie, you're going to be kind enough to advance the slides. First, I want to welcome everyone. Thank you so much. If you want to ask a question, make sure that you put it into the chat or you can raise your hand. Again, I'll do my best to make sure that I'm manning this. Typically, Laurel is manning the Zoom calls. I'm going to try to do my best in her place. A Greener Space Builds. For those of you who are not familiar with the Greener Space Builds and the Macario project, if you missed any of our first sessions, just a really quick introduction. We are a different kind of developer. We are a bio-based and low-carbon mineral-based builder. We focus on those materials and try to give space to experiment with them to create buildings that are rich with data for this type of construction because we just do not have enough of them in the world. And we really are here to elevate and broadly expand the adoption of bio-based materials. That is our goal. We can't do it alone. We have an amazing amount of partnerships, and a few of those on the next slide. We're happy to announce that we have some new partners that are working with us. But if you are interested in helping us, do not hesitate to reach out. You can contact me directly through my email on the A Greener Space Builds website. Because in order for us to scale in a way that we need to, we really need to have a group of innovators who are working with us. There's plenty of work to do. There's plenty of opportunities, so don't hesitate to reach out. I'd love to hear from you. Our amazing team. If you joined us on our previous meetings, you will notice that this slide keeps getting bigger and bigger. Our team is growing, and I am so excited to say that as of our last meeting, we have 4 new instructors, 4 new team members, and that includes Chris Yosef, Chris Magwood, Rodrigo Dañado, and Esteban Martinez. They are going to be helping us respectively with embodied carbon, inclusive of dynamic carbon calculation, which is really exciting. The development of potentially the world's first PCR for non-industrial materials, hydrology and permaculture. Rodrigo is world renowned. We are lucky to have him. And Esteban Martinez, hailing from Colombia, who's going to be helping us with energy modeling, again, with materials that typically tend to be a little difficult because they don't fit in the conventional terms of energy modeling. So with that, I am going to go ahead and pass it over to our 2 presenters. Santi and Eddie, please take it away.
Thank you so much. And Jeanette, can everybody hear me? It's okay. Quick hello. Really happy to be here. We're one of the partners in this amazing mission called the Macario Project. And today we're going to be going over quickly over a very big topic. It's going to be a bit hard to cover everything, all the details. I could go on and on for hours. I promise you guys will finish on time. But yeah, please keep in mind we're going to try a pecha kucha style. So it's going half a minute or a bit more over slides, visuals. We'll try to share as much as we can within the limits. And of course, we're going to have a Q&A at the end. And hopefully we'll see several of you in person next year. So we'll have more time to go deeper into these subjects. So we are Hecho en Tierra. Hecho en Tierra is an architecture and construction studio based in Mexico with a big focus on earth and construction. Hecho en Tierra means made in earth in Spanish. And this is the team. I'm Eduardo Barba, Eddie. I'm a Swiss Mexican, a builder and entrepreneur with these aspects. And here is the founder, Santiago.
Thanks, Eddie. Hi, everybody. Really happy to be here. Yes, as Eddie said, I'm the founder of Hecho en Tierra. I've been working as an architect and researcher and teacher, trying to bring Earth back to our hands and to build with it since 10 years now. And I'm really excited to be a part of this group and this project, this effort to try to do things differently. Today, I would like to start the conversation with telling you why I think building materials matter, why it's important for us to choose properly our materials, and I think this is a perfect platform to do it. So I mean, I guess everybody here has heard about climate change. We have more and more disasters everywhere in the world happening as we speak. They're bigger, they're stronger. Now we have mudslides, we have rivers overflowing, we have fires in LA, we have Category 5 hurricanes. We also have some man-made destructions happening. And it's not only what we're doing to the environment that is causing this, but we also need to start questioning ourselves. What are we doing with all the debris and all the waste that this industry is creating? And yeah, what's going to happen to all of this when this is gone, right? So I will jump back a little bit in history and say that since the beginning of humankind, 200,000 years ago, humans have been building with natural materials. Earth, for instance, is the most abundant material in the world, and we can work with it in so many different ways. We have this example in Tunisia where the soil had such properties that people could dig into the mountain and live in caves. Then these techniques have evolved into the resources that people had and what was available to them. We have this amazing building in Alhambra where Anjanette is at the moment, I think. And I really love this picture because you could really see what the mountain down there, you can see the color of the soil being brought up to the walls of this great city. Earth has been used to build cities, to build temples, as we're going to show next. It's a material that it's very easy to work with, and depending on the climate that you live in, you can do with it as much as you want. This example here is Shibam in Yemen. They call it the Manhattan in the desert, and it's all adobe based, and they have 15-story buildings here, and it has been there for thousands of years, and it's still working. And also building these buildings so tall creates a shade on the bottom that it's keeping it cooler during the hot summer days. So the environment and the materials that we have within our hands help us shape our cities. This is the Janneh in Mali. I think it's the biggest temple built with natural materials. And there's something that is really fascinating about this building is that it's built with a technique called cob. And every year at the beginning of a rainy season, the river is gonna wash away and really create the perfect properties for soil to be used and to recover or replaster this whole building. And it becomes kind of like a village activity. Everybody is going to the river, getting mud balls, and then bringing it back to the mosque. And there's people climbing on it and putting it in. And this way, they're gonna protect it till the next rainy season comes. And this has been done for I think 1,500 years. So there's a lot of myths saying that Earth won't last, but I think it's these myths that we really have to fight against. And if it's done correctly and used properly, then we can make it last as much as we want. In history, this is what we had known for thousands of years, right? 90% of the time that human as Homo sapiens have been on this land, we have built with natural materials. And in the 700s, the industrial revolution came, and this made a huge change in humanity, not only in the way we build, but in the way we live and how we consume. And I'm not saying it's necessarily bad. It brought a lot of really good things to the world and to what we are today. But it's definitely, this is a period of time where the decisions that we started making shifted to what we're living on today, right? So it was not only the material industrialization, but we also started to industrialize how we lived, the typology of the houses that we use, how we consume food, and etc. Right? So we could see this effect happening in a lot of industries. And in construction, it was no difference. It's beautiful. We had the steel era, and we have these amazing structures that could be built, like the Golden Gate building or all of New York or everything around the world, really. And it's really, really amazing. But I think we, as of now, and how heavy we're going on the extract of these minerals and so on, we have to think twice. This is the first reinforced concrete built in Paris in the 1800s. And this was a big boom for construction. It was the first time it was done. And here it was where they told us that concrete could solve everything. And I could say, yes, it can. It's an amazing material, but should it solve everything, right? I think this is a question to ask. We have so many different materials that we could use. Not saying that concrete is not amazing, but I think we need to start to question a little bit more where and how we're using it. We can see amazing engineering projects like this one in Mexico City, where the soil is super hard and this is all steel and concrete, and this is really great. I think humans need to keep on developing in this way, but we also see what's happening in a lot of parts of the world where the materials in a positive way are giving housing to a lot of people, but they're also not responding necessarily to their needs or the climate or the geography or what's happening under those tin roofs. And I guess this is very political, and it's where the money has been invested in history. But I think now more than ever, we really need to start thinking for better solutions, not only for the environment, but also for the human beings. The construction industry is one of the industries that has a major impact on climate change, right? It has to do with 40% of the energy consumption in the world, for the waste creation, for the resources used, and for 40% of the CO2 emissions to the atmosphere. But it also represents 20% of the work for the humans. And it's estimated that humans spend 90% of their time in built spaces. So if we are creating so much jobs here and we're spending so much time in the buildings, in the built environment, this means that it can also be a significant agent of change, right? We just have to start pushing and thinking about it a little bit differently. And I would just invite everybody to not only, I think it's good that we went and start thinking sustainable, getting to the net zero, but we really need to start thinking about regenerative. And by this, I mean how to improve social and environmental well-being, with a positive impact. We cannot be comfortable with net zero. We have to push a little bit harder and try to create a positive impact for the environment to be able to regenerate itself.
Thank you, Cari. That's where I'm going to jump in now. Please let me know if it's cutting a lot. I'm going to try to speak slow. I think I have the worst internet. But this is exactly it. We really believe earth construction is a major part of that solution, not the one and all solution for everything. But if you think about a lot of bio-based and natural materials, you always have to look at what's available locally. And earth happens to be that material that you'll find on every continent in this world. We love other materials. We always try to look into the local fibers that are available, and bamboos and wood sources and agricultural waste streams. But at the end of the day, earth is that one component that we can really rely on. And that's what our passion is about, to try to help promote this. There's a lot of lessons learned. There's the good and the bad. There's a lot of details to take care of. Sometimes it comes down to how you just mixed the earth mixture. If you mixed it by foot, you mixed it by machine, it changes completely different. I can be using the exact same mixture of earth on a job site. 6 months later, it'll start acting differently because I'm realizing the earth is starting to be different. From 1 meter to the next, it changes. So it really invites us all to get a bit closer. Santiago was saying the heritage of earth is incredible, and that's no different in Mexico. If any of you ever had the pleasure to see the Teotihuacan, the Great Pyramid of the Sun in Mexico City, and you walk to the back side of the pyramid, you'll see that really it was made out of earth, adobe style blocks. And it's still seen today all over Mexico, where I'm based currently. It's in the coast of Oaxaca. There's many colors and flavors, that's how we say, of earth. There's purples and the traditional kind of more yellowy tone, and you can see that people haven't lost knowledge completely. It's trying to be used in conjunction with contemporary materials and techniques. Sometimes it works, sometimes it doesn't. And one detail here you can see is that the earth isn't sticking well to that concrete pillar. There's a reason for that. We might need a transition material. They act differently. Doesn't mean the earth doesn't work here, is that maybe it requires a bit more. So earth can take many different shapes. The earth block is a cast earth block. This is poured as if it was poured into a mold. You let it dry and it becomes a hard block, smooth like that. The blocks to the right, they have a bit of fibers. They're sun dried over a month. No, it's just a different style. But as Santiago was talking about, this is a material seen all over the world. In fact, it's calculated that half of the population is living or has lived or has built an earth abode of some sort. You can see all these areas in the earthy color. And this little table is a quick summary, but there's more techniques. It's just a summary of all the techniques of earth. So if you go in the middle, the common denominator is soil. As you can tell, the first inner circle, it says form, pour, extrude, stack, compact, cut. And you can see a couple of the names of some of the techniques you might recognize, like rammed earth, right? Rammed earth is under soil, compact. It's a dry mix, and it has this mechanical component added to it to force the particles together to have a cohesive block. In the case of an adobe, for example, you just really need to shape the earth, take away the mold, and let it dry. In the case of cob, is the exact same thing at a much bigger scale. You're not doing individual little blocks. You're stacking up balls of earth onto the wall and creating a monolithic structure. There is also a little reference at the bottom, talking about what's monolithic, what's masonry, what's filling in. There's many different techniques and ways to use the earth. It's one big rule of thumb is to not necessarily adapt, like kind of force the earth technique that you like to your local earth, your local conditions. Usually what's best is to adapt the technique to your local earth. So you have to also keep in mind what makes sense. This is something I've fallen for before, because maybe I'll get married with one technique, but you also have to have this relationship with the earth of understanding what it's made out of, what its characteristics are, and how best to work with it. These are a couple of things in Spanish, so hopefully in person we'll have a bit of an earth course and slight Spanish course, but let me translate. What is earth made out of? It's made out of stone, gravel, sand, limes, and clays. Basically has to do with the size of the particles. Here you have an idea, and it's not just the size of the particles, but if you can see on the left, all that is gravas, arenas, limos, which is sand, gravel, limes, is a bit of let's say irregular structure, like little stones. They go from big rocks to little rocks. The clays, arcillas in Spanish, the clays on the other side are, if you see it in a microscope, they're little plaques of structure that if you think of one plaque of glass and you put two pieces of glass together with a little water in between, what happens? It's almost impossible to separate them. That's exactly what the clay is doing. The clay is our gold, is what allows the particles to stick together. And that's a big important component for us always. It doesn't always mean that more clay is better. It can be counterproductive as well. But just to summarize, that basically earth construction is a consolidation of all these different sizes of particles, and we're trying to create a mass. We're basically creating stone by hand and accelerating nature's processes. So I'm going to go over a couple of the techniques quickly to give you guys a little overview. This is cast earth. This is one that we did a couple of years ago. It has rice husks and earth and a bit of lime, and it's cast just like in concrete. Some people are already taking this to a bigger scale. This is a project done by Francis Quere, a Pritzker Prize winner now in Africa. And you can tell the size of the formworks and the size of the pour, right? It is possible. This is the kind of scaling that we'd love to be a part of promoting, right, with the Macari project. This is another technique. It's called wattle and daub in English. Here it's basically kind of like an adobe, same kind of plasticity, more mixed with water, some fibers, but if you can tell, it's thinner because there's a substructure. To the left is an experiment we did. It has recycled plastic nodes and rope. The right is a structure here in the coast with coconuts helping to fill in, and some palm and some earth. Dug in there. That wall stood a long time. Big hurricane came, hit it down. It can happen, but it's also a technique that allows it to be very repairable quite easily. A good technique also in seismic areas that has a bit of flexibility. Then you can take, let's say, the fibers to another level, having a lot more fibers. Here we're getting more close to light earth building techniques. We call it light earth. It's a lot more fiber than earth. And as you can tell, they have a little plaster on the end. So this is also, this is straw bale, particularly, but it's one of the techniques, that falls under light earth building. Obviously, we cannot forget plastering, the last layer. It's like it's like almost a paint, of earth. There you do want more clays. It's more mixed with water. It's finer. It's sifted more. If you think of other techniques, you want more gravels, more stone for a bit more mechanical strength. This is more like a paint. Here, in this case, they're plastering an adobe wall. This is exactly what Santiago was mentioning about the mosque in Mali, that they come together and replaster. Exactly, breaking our ideas of maintenance being a bad thing versus maybe maintenance is a good excuse to bring people together and take care of things and where you live. Here is a technique similar to rammed earth in a small scale in a block, dry technique. It doesn't have fiber because it's getting its cohesion thanks to the mechanical strength. In this case, Santiago and I were producing compressed earth blocks over a year, trying to scale the material in the coast. In this case, we stabilized it. That's a word that you may hear a lot. Stabilization usually means you add cement or lime to help make it even stronger. It was a big challenge here with working with this material in the coastal area. And if you see here, we're taking it maybe to even another extreme of technology. But now there are even 3D printers dedicated for Earth. Ronald Rayel is a very famous 3D printer with Earth based in California. To the left, these are some experiments I did in my previous like R&D with Manufactura. In this case, we were 3D printing eggshells, not technically Earth, but I kind of want to make the point that there's a spectrum of techniques, and earth plus fibers and plus water and more mechanical, and it's not exactly perfectly defined techniques sometimes. The boundaries can be blurry, and there's a lot more knowledge to recover from the past, but also innovation and trying to bring this to contemporary architecture, which brings us to our focus.
Yeah, thank you, Eddie. I guess I'll take it from here again. So yeah, we're gonna talk about rammed earth. I first saw this technique done 15 years ago in Europe, and I fell in love with it. And I started researching about it and understood that it came from China, that actually parts of the Great Wall of China are made with rammed earth. And as China was conquered by Genghis Khan, and he conquered all of Asia up to the Arabic world, the Arabs took it to Europe, to southern France, to Spain, and that's how it became worldwide known. But it's a technique that it probably has 5,000 to 7,000 years, and we can still see structures built with this technique from that long ago. Since I learned this, I decided to make a trip to, not to where it all began, but to a region in the world where rammed earth is their main construction technique. It's in India, in the Himalaya of India, and it's a city that is 3,800 meters above sea level. That would be, if I'm correct, roughly like 16,000 feet above sea level. And in these high deserts, the only thing that they have is some wood and earth. And I visited this school where everything was made with rammed earth, and they had a temperature, sorry about this, I don't know in Fahrenheit, outside of the school of minus 15 Celsius. And inside the school of the classrooms, it was above 15 Celsius. So it was like a 30-degree change without any heating systems. And I was able to participate in a lot of workshops, and it was really fascinating for me to see, from kids to women to monks, everybody playing with earth and just feeling so familiar with this material, and having to see this joy in their faces when they were in contact with the material just really made me think about how special it's to connect with our hands and with what we do. After this project, I went to Nepal, where a Nepali constructor started building with rammed earth after the earthquake in 2015. And I joined his company and his work, and he really works in remote areas where the earthquake hit hard, and he works mostly with women. And I joined in a lot of his projects, and it was fascinating to see that between a lot of hands, we could make something happen. And it didn't need to be as technical as what I had been taught in the Western world, and only guys can do construction and so on. Here it was, we were a whole community building, and within some months of work, we managed to raise up a building, and this was super fascinating for me to work and to see, and it's really what pushed me to move on forward, wanting to work with rammed earth. Not only that, I'm also an architect, and I really think it's beautiful how this technique looks in the end. But I was young and beautiful, and I needed to experiment this. I needed to experiment building a building for myself, also to be able to teach. Technique hasn't evolved too much since the Chinese area. Basically, you extract the material from the soil. If you have the right proportions, you're gonna mix it with a little bit of water. You're gonna put it into a framework. You're gonna ram it, and you're gonna move this framework away, put it on again in the construction site, and keep on going. Right? I wouldn't like to say there's a proper mix, or because it's really hard to say this, because every soil in the world is different, right? As Eddy was saying, you can dig here, and 1 meter there, the soil is going to be different. So you really have to take care on how the mixture is done. But usually we're going to want in between 10 and 20% of clay in this mix. Then we're going to want around 50% of sands in different sizes. And then we're going to want 20% gravel and 10% silt. And you have to really be careful with the water. This is a technique that is really made almost dry. So if you get it wetter than it should be, it's going to be impossible to compact. And the technique is really, really simple. You pour around 20 centimeters of earth into the formwork, and you're going to compact it until it goes down 50% of the volume. And then you're going to add more earth to the framework. You're going to compact, and this way you're going to be building like the layers from bottom top until you finish your wall. It has a lot of benefits, not only for the environment. The idea is that you could take out the soil that you use for your foundation, that you're going to have to dump it somewhere anyways, and you could use this as a building material. But it has a lot of thermal mass, meaning that it has the capability of retaining a lot of heat during the day and slowly releasing it into the house or the room during the nighttime. It regulates the temperature as well as it regulates the humidity levels. It has an amazing acoustic barrier. It's fireproof because earth doesn't light up. It doesn't have any organic matter in it. Actually, in LA, they're starting to think a lot about building with earth for this reason. And as I said at the beginning, the idea is that you can take the resources that you use for digging your foundation or your cistern or whatever you need to dig up, and you can use this to build your walls.
So I'm going to talk about tampers. Pisones is tampers, and different sizes, different shapes for many different little details. No, it's at the end of the day a very simple technique, but the quality that you'll get and the experience and just yeah, the quality of the work can vary greatly depending on all these little details. When you don't use the smallest head of a rammer to ram the corners, which applies the biggest pressure on areas that maybe the big mechanical pneumatic tamper gets, it just won't come out the same. So even when using pneumatic tampers and using machines, there's always a lot of detail that goes by hand, of retouching, of ramming by hand the corners. And yeah, it's very, very important to do every step. The earth is very, very jealous. The moment you think you've got it all figured out, you're maybe a bit confident, you forget a detail or two, and it punishes you. So I love that about the earth. It really keeps you on your toes. You really need to maintain a relationship with earth. It even happens to me if I spend a couple of weeks without working with earth, I need to get back into it a bit, at least understand what earth I'm working with. So the tampers are hugely important. The properties of the earth is hugely important. One maybe major detail I didn't mention is obviously we do not want topsoil. We do not want soil that's for food. We want soil that's under, no? And ideally, exactly as Santiago said, soil that's already been extracted. There is a crazy amount of excavated soil that we're not taking advantage of, especially in developed countries and also in Mexico. Back to the point here, we're in formworks, cimbras in Spanish. There's many different ways of doing it. Here are a couple of examples from workshops. You can do it a whole monolithic or be ramming a section and go kind of in line. And here's another example. This is a project we did for one house. Yet another a slight technique here. We bent plywood to create this little effect. We mixed the earth with different mineral colors to create this effect. There's also obviously the very modern prefabricated scaled solutions. This is probably the biggest scaled rammed earth manufacturer and practitioner in the world. His name is Martin Rauch. His company is called Lempton Erde in Austria. They have a massive machine that they prefabricate 40-meter long walls, 1 meter and a half high. This is rammed by a massive machine over a day and a half, and then it's cut into these segments that you see that are 60 centimeters thick with a giant saw and transported on site with a huge crane. This is not something that we're used to here in Mexico, wouldn't work for us, but I do think it's very interesting how people have found solutions, no, to bring it to another scale. Here you can see how they literally stack them up like Legos and then do the retouching. No, that's we refer to retouching. What's beautiful when you do not stabilize rammed earth with cement or lime is that once you retouch it after, you get the exact same mixture that you used to ram. You get it wetted again, you ram it into the corners, and it'll completely disappear. You won't see where the cracks were. So it's highly recommended to do it that way. Here on the right is another project in Switzerland. They're experimenting with different hybrid solutions. I think it's very interesting, to think of how it can come together. In this case, there's no structural column, but they're using tension to pre-stress the rammed earth blocks. So if you see the wires are just bringing it all together, there's no column. I think it's super interesting, especially in a seismic area, but there's definitely a lot more to look into. But without further ado, let's maybe we'd like to go super quick over some projects. Santiago, do you want to share the first one?
Yeah, this is a project that I really like because I would say 90% of the materials came out from this same lot. As you can see, there's a little lake on the front. Where they were digging up that soil for the lake, we used that for the rammed earth walls, and all of the wood from the beams in the roof came from the same forest. So this is and the only thing we used that came from outside was concrete for the foundation. So this is a project that was really, really nice to work in that way. It's a private spa for a ranch in a town close to Mexico City. And in the same project, I was able to work with rammed earth in a smaller scale using the earth bricks, compacted earth bricks, and it was to create this dairy farm. And it was amazing because these bricks had they were casted in this way that they had like ribs on it, so we didn't need mortar to make the joints. They would just hold within each other, so it was really, really fast to build with this method.
Here's another project. This is a hotel here in Puerto Escondido on the coast. A bit of a greenwashing project, to be honest, because the whole structure is reinforced concrete, but they asked us to come in and wrap up 13 villas with rammed earth. It wasn't perfect, no, but I think it is important to try to put earth more out there. They didn't trust in the earth mixture on its own. They wanted us to add more cement stabilizer. It's a shame, but it's at least a small step in the right direction. And maybe the most important impact in this project particularly is it serves for people to see earth in a different way. In this luxurious setting, not very boutique, fancy hotel, and perception of earth can change. But a lot went into this. We mixed 60% of the local earth from the local hill nearby with a 30% earth that we knew that had a bit more properties, and we wanted to get a certain tone. So it was working very closely with the builder here, and they wanted little strips put into the formwork. It was very complicated. The steps obviously could be designed differently. I would say there's a big aspect to consider of designing something and then finding the way for earth to fit to your design, or designing with earth in mind from the very beginning. Here was very challenging to come in after. I just would stress that there's a timing aspect to this. Yes, maybe it'll take more time. It's not something you buy off the shop, but if you go through the processes and you understand your earth and you do your test, you can really build ground up at I say a more earthly pace. But moving on, what's next? We have hopes of just getting our hands dirty more and more. There's a few design projects happening right now for another coastal town in Mexico City. We're doing a couple of training courses for construction teams, and just trying to fund that educational aspect. That's where we hope we'll meet all of you very soon. And this is something that's being built right now using the earth that excavated with a stone foundation, minimizing the concrete and just to hold the wooden pillars. And yeah, we're just super excited to share a lot about these details with you, a lot of the lessons learned. And this is the Macario project.
Thanks, Eddy, and thanks, Santi.
And Jeanette.
Thank you, thank you. This is amazing. I warned everyone that this was going to be fast-paced with lots of images, and you dealt with your Wi-Fi very successfully. Beautiful segue into the Macario project. Again, we are building our first project in Macario Gomez, Mexico, which is about 21 kilometers away from Tulum. If you're familiar at all with the Mayan region and Quintana Roo, that is where we are going to get our hands dirty. So there's lots of ways that you can get involved. You can support the project if you are a professional and join us on site. We will keep the participant list very small. We're maxing out at 15 people per month for the build. So you will get the type of instruction from Santi and from Eddy. And if you listened to our course last week for bamboo from Miguel, you will get intense training and learning and have an experience with an actual finished build at the end. We're not making prototypes. We're not making small little models. We're making a building. For academia, as I mentioned, we have people on the team who are going to be dealing with all of the data to help move the needle with respect to the information and filling a lot of data gaps. If you are interested in a research project or a white paper and you need a project that will serve as your demo, please let us know, because we would love to partner with you for that. If you're a manufacturer and this is of interest to you and you are looking for some place where you can pilot or test performance, please call us. We'd like to talk to you as well, especially if you are in the region. And if you are somebody who would like to use the space afterwards, perhaps you would like to have a wellness retreat or you're a yoga instructor. The building is meant to be enjoyed by everyone in the community after it's built. So I'd love to talk to you about those opportunities as well. The next slide is just going to be talking about registration. Please go to the Greener Space website if you would like to let me know that you want to sign up to be part of the on-site instruction courses. Special announcement, we have determined that we are going to start our first course in March. It's earlier than we anticipated, but we'll have our first on-site session on the ground in March. So plan accordingly. And in April, we will be putting down natural water systems. So we plan on working together with those 2 months first in mind. Stay tuned. I'll be sending out registration links for those who have already posed interest and get you signed up as soon as possible. I can't stress enough how excited I am that we're going to have these instructors on site. It is the chance of a lifetime. So please reach out and join us. And with that, we have a bit of time left for some questions. So if you have a question, you can feel free to take yourself off mute and you can ask. It's always nice if you can turn your video camera on so we can see your face. And I think if there are questions in the chat, I can pose those as well. Yeah, so just on-site courses, 1 week, 2 week, 3 week, 4 week. Let us know what you'd like to do. Lots of opportunities where you can come down. All inclusive, we'll feed you, we'll take you to and from the site. It's going to be a really great experience. Any questions that we can actually give our attention to? Don't be shy. Please reach out. I'm seeing lots of compliments, but please let me know if there's a question that you'd like to ask. I have a question. There are probably some questions about cost. How would you recommend people understand how to do cost estimates for a project? And given that this is a regional material and hopefully you're not shipping it in from far away because that would be counterproductive, how would you recommend people talk about pricing estimates for a material like rammed earth?
That's a tough one, I have to say. As Anjanette was saying, it's original material, and it's hard, at least here in Mexico, when you're gonna start to build or something. Everybody asks, "What's the cost per square meter?" And with rammed earth, it's a little bit different because, first of all, you have to know what soil you're going to be working with, if the soil on site works. So you have to do this previous work that you usually don't do with a cement concrete building. So you have to do like a soil analysis. You have to get, if it's a structural building or you're going to use rammed earth structurally, you have to get these cylinders to the laboratory to be tested for compression. And then from there adapt the mix to get to the numbers that you want. If the soil on site is not working correctly, you have to bring soil from elsewhere, and the cost is going to vary in this way. So it's really tough to put a number on that. And then it also depends on how you're building it. If you're using the pneumatic rammer and you have two of these, and the labor is not going to be as intensive. But if you have more hand labor and you're going to do it like this, I don't know. There's so many things in play that for me it's really tough to calculate. In Mexico, as of now, with 5-6 different buildings in different regions built, I have already like a parameter cost by square meter. But I can tell you that it has gone like from $300 per square meter up to $800 per square meter. So it's that big of a difference in different regions and what you're building with, that I wouldn't like to give you an answer to that. If you come to the Macario project, then we would definitely see everything that you need to take care before and during the process to make your budget correctly, right?
Yeah, well, we'll have to. But that's part of the data. Part of the data output is, cost is
Yeah.
always the question. It's always what people want to ask. So I went ahead and asked it. It did pop up in the sidebar here. So I appreciate that. It's very contextual. I know some exercises that Eddy and myself have done for projects. What we usually do is compare the cost for concrete, and the material itself is not necessarily the cost. It can be the fact that you have intensive labor. So depending, again, regionality, sometimes labor is quite cost effective in some areas not so much. So thanks for that. I know
Absolutely.
that was a hard question. I didn't mean to
It's all right. No, I mean, this is a question that everybody asks, but I also like to see it as in the future, right? And it depends a lot on the design, but how this earth building, how is it going to work, and how less time are you going to need to have the AC going on, no? And so in the future you could really calculate the energy needed to maintain your space, and maybe you need 50% less of AC in a earth building that you wouldn't, and then you can start making calculations, and maybe
Yeah.
it's a little bit more expensive at the beginning, but in the lifespan of the building, then it's a little bit cheaper. So I think it's over the time that you have to make these calculations as well.
Agreed. Operational carbon,
Yeah,
operational costs. I think these are really
exactly.
important things to ask, and lifespan of the building. I have a great question here from Luis that I want to pose is asking, can you talk about foundations of the building for this type of structure? What kind of foundations are we looking at? I think the saying goes for bioconstruction, you need good shoes and a good hat. So I think the foundation question is a valid one.
Absolutely. You can work. I've worked the foundation with stone masonry, and with concrete. It depends on the region and what materials you have available. In Nepal and in India, we're working a lot with stone. And here in Mexico, we do it more with concrete. People are used to working with this material, and somehow it feels safer structure wise in this like really seismic region. But what really is important is that you need to get this material, either stone or concrete, that it's not letting the humidity pass from the bottom up to the wall. Because if you get some humidity through that foundation and into the wall, into the structure of the wall, then you can really have like a structural fail, and that would be very sad.
Yeah, that is, I think the first thing to understand when you're building with bio-based materials is that you need to lean on the wisdom of the past, and we do have some examples, but I think trying to um, again be respectful of the very specific and unique scenarios that it poses. I think there were some
Absolutely.
really beautiful quotes in this presentation today. I'm glad it's recording because I want to make t-shirts out of some of them. I think having the respect for the land, and also I've long been an advocate for a building that naturally decomposes. I know it's just completely
Yeah.
counterintuitive, but I do think it's an opportunity for people to come together as a community and pass along the knowledge. It's okay if something ages. It's okay if it has patina. It's okay if it breaks down, if you're working with materials that can be repaired. So I think that's a really important lesson. Brings me to a fun question that might be, is our final thought is, what's your biggest surprise or unexpected aha moment? And maybe we'll have both Santi and Eddy ask that in the last 4 minutes that we have before we say goodbye.
Eddie, you start.
Let's see if the video. This is a good one. This is a good one. It cost us. It was a costly mistake. Um, there's an expression here. Yeah, we kind of fell for the trap of the limes, making the compressed earth blocks. We got this. We were testing this earth. We were doing plasticity tests, a lot of field tests that we'll go over to understand, and the cohesion it has, the elasticity. Okay, it seems like it has clay. Perfect. It's sticking. It's working. We compress the blocks. Perfect. They're coming out great. But we realized over time, 6 months, the blocks that we made 6 months ago started like losing its cohesion, it like breaking apart a bit of the edges. We figured out we fell for that trap. They were lime, a lot more lime than clays. That was one thing. So one little test that you can always do to distinguish the difference is putting a tiny bit of that clay substance in your mouth. Silt will feel a little sandy, clay won't. Even that, but obviously way better than that is doing all the lab tests. Here we went straight for compression tests, but you can go so deep into the world of clays, and not all clays are the same. Some are expansive, which means that when they dry, they tend to crack a lot. So that can be problematic, but it can also be helpful in other situations. But that field clay was a bit aha moment that it's not so, yeah, not so obvious, and lab tests are definitely necessary.
And I would say for me, it was in this India project. I went there after finishing my master's in Switzerland and so on, like coming out of 8 years of school, super prepared, but I was really not sure why I had studied architecture and if I wanted to be an architect. And being with these kids and people that had built their school with 0% cement in their classrooms and in their buildings, and having it been done by their own hands, and just being in that energy was like my big aha moment. It was like, oh, this is why, right? Now I'm here. Now I want to share this with everybody.
Amazing. I can't think of a better note to end on. I feel like with all of these sessions, they could go on and on and on. The whole point of these sessions, though, is to get enough interest so that you feel empowered to reach out to any of these experts. You feel empowered to reach out to me at A Greener Space, that you spread the word and share. We'd love to see more people join us either online on the sessions or on site. I'll be opening registration online very soon, so stay tuned for your spot to come and join. But as usual, very impressed with the talent that we have on the team, and couldn't be happier that everybody is here to learn and express an interest in how we can elevate bio-based materials. So thank you again to Eddy and to Santi. Thank you everyone who joined us. And
Thank you.
we look forward to seeing you in August for our next session, which is going to cover bagasso, which is a agricultural waste fiber, and who our presenter will be is Ashley Javogue, who hails from Costa Rica. So registration for that is open. It's August 13th, and we will see you then. Stay cool, stay safe, everyone, and hopefully you're in a good air quality space. Thanks, everybody. We'll see you next time.
Thank you. Ciao, ciao.
Thank you.